what's up. Like, how about the sky? Get it? What's up? The sky? Not only am I the greatest intergalactic spaceboarder in the universe, but I think I'm probably the funniest too. I should probably introduce myself in case you haven't already heard of me. I'm Jet Space Jammer, master spaceboarder and all-around awesome dude. My intergalactic, supersonic, solar-powered spaceboard can go anywhere in the universe. But that's not what I want to talk to you about. I really want to talk about what's up. I mean, have you ever seriously checked out the sky before? Well, there's a lot more to it than flying birdies and the color blue. For one thing, our sky is really a bunch of layers of gases and water vapor that surround the whole Earth. It even has a fancy name, the atmosphere. I'm going to tell you all about it and ask you some questions along the way, so pay attention, dudes. According to my Megadad Aristotron, Earth's atmosphere took millions of years to become the way it is today. Wait till I tell you how scientists think that our atmosphere developed. But I have to warn you, it's kind of gross. Okay, here goes. Scientists believe Earth released, or burped, up gases such as nitrogen, carbon dioxide, and sulfur dioxide over millions of years. Somebody give that planet a breath mint. Comets and meteors that hit Earth also released gases. Eventually, plants and other life forms came along and changed the atmosphere to what we have today. It took millions of years for Earth's little gas problem to create an atmosphere that makes life possible. Without it, where would all those cool plants and animals be? Not here, that's for sure. Let's see. My Megadad Aristotron says the atmosphere is made up of 77% nitrogen, 21% oxygen, and small amounts of other gases and water. That special combo of gases creates the air we breathe. Dudes, all living things need to breathe to live. Because of our atmosphere, we breathe and we live. Not only that, but the atmosphere acts like an umbrella, protecting us from dangerous rays of sun and stuff falling from outer space. Check it out. If Earth didn't have an atmosphere, it would be so hot we couldn't live here. Which wouldn't even matter because meteoroids would come crashing to the ground and probably destroy the planet. Whoa, can you say duck? Since we do have an atmosphere, most of the sunlight is absorbed, so our planet won't get too hot. And most of the stuff that collides with the Earth gets burned up in the atmosphere before it can hit the surface. Dudes, it's like our atmosphere is a superhero. Burning up asteroids, blocking dangerous sun rays, leaping tall buildings in a single bound. Oh, wait a minute, that's someone else. Anyway, another thing our atmosphere does is give us sound. One way sound travels is by air. No air, no sound. So if you go to the moon, you can't hear anything. There's no atmosphere there, which means if I were to stand on the moon and sing la 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 la, you wouldn't be able to hear me. But dudes, I should tell you, that's probably a good thing. I just thought of something. If we didn't have an atmosphere, I would never hear my mom calling me home for dinner.
Jet, it's time for dinner.
Dinner. Oh, sorry. Anyway, the atmosphere does other things too. Yeah, it recycles water and acts like a giant thermostat controller, which keeps Earth's temperature pretty comfy. And while letting in just enough heat and energy from the sun, it also insulates us from the freezing temperatures of outer space. One thing the atmosphere can't do is insulate you from some quiz questions. Get your pencils ready, dudes, because here they come. Question 1. What is the atmosphere? Is it A, a layer of water that covers the Earth. B, the temperature of Earth's air. C, layers of gases and water vapor that cover the Earth. Or D, all of the above. Question 2. Scientists think Earth's atmosphere was created from A, the Big Bang, B, the Sun, C, released gases, or D, a supernova. Question 3. What are the two main gases that make up Earth's atmosphere? Is it A, nitrogen and oxygen, B, helium and hydrogen, C, carbon dioxide and sulfur, or D, methane and propane? Question 4. Why is the atmosphere important? A, it provides air for living things. B, it shields Earth from the sun's harmful rays. C, it protects us from falling objects from space. Or D, all of the above. Okay. Question 1. What is the atmosphere? I hope you answered C, layers of gases and water vapor that cover the Earth. Don't always go for answer D just because it says all of the above, dudes. Question 2. Scientists think Earth's atmosphere was created from... Remember the burp theory? The best answer is C, released gases. Question 3. What are the two main gases that make up Earth's atmosphere? You should have answered A, nitrogen and oxygen. And question 4. Why is the atmosphere important? Well, here's where you should have answered D, all of the above. It provides air for living things, it shields Earth from the sun's harmful rays, and it protects us from falling objects from space. Dudes, before we get back to the atmosphere, I gotta tell you about one of my favorite things to munch on. It's called a Galaxy Crunch Supernova of Chocolate Bar. You know what makes it so drool-worthy? All the layers of stuff. There's marshmallows, chocolate, caramel, coconut, more chocolate, nuts, crispy things, more chocolate, and whipped cream on top. Whoa, I'm getting dizzy thinking about all the layers. Sorry, lost my head there for a moment. Can you guess what Galaxy Crunch Supernova of chocolate bars have in common with the atmosphere? Layers, dudes. Yeah, the atmosphere has a lot of layers. Check them out on my Megadata Aristatron. There's the troposphere, the stratosphere, the mesosphere, and the thermosphere. And the thermosphere is divided into two parts, the ionosphere and the exosphere. The atmosphere is way over 350 miles high, so I think you need a closer look. So I, Jet Space Jammer, Master Spaceboarder of the Universe, will take you on a tour of each layer of the atmosphere. Hold on tight, dudes. Here we go. Whoa! It's kinda windy up here. This is the troposphere. There's one thing you really need to remember about the troposphere, is that this is where you find most of the weather. In the bodacious troposphere, air currents move around the planet creating fronts. And depending on how everything mixes together, you can get rain, wind, snow, sunshine, or even more gnarly things like hurricanes or tornadoes. Tornado! Let's get out of here! Okay, it's a little calmer in this part of the troposphere, which is good, because dudes, we need to talk about water. H2O, agua. The wet stuff. Here in the old troposphere, Earth recycles its water. Yeah, the process is called the water cycle. We have the same water that we've had since the beginning of the planet. You're thinking, no way. But like, way? The water you drink today is the same stuff the dinosaurs drank. The water cycle just recycled it. Pretty cool, huh? I wish I could recycle Galaxy Crunch Supernova of chocolate bars. They're so chocolatey. Chocolate. Sorry. You know what? I have a totally awesome idea. Let's look at the water cycle. My Megadad Aristotron can show you the whole thing. Here we go. Water evaporates from lakes, rivers, and oceans. Hey, wouldn't it be cool if your homework could evaporate? Anyway, the water that evaporates turns into clouds. This step is condensation. The water in the clouds falls back down to the earth as rain, snow, hail, or sleet. That's precipitation. And that falls in the lakes, rivers, and oceans, or the soil soaks it up. That's collection. Presto changeo. It keeps going over and over again and again. There's no start and no finish. So the troposphere gives us the weather, the water cycle, and, well, you're breathing it. That's right, the troposphere is where we find the air we breathe. Hey, without it, there wouldn't be much going on around here. Yeah, Earth would go from looking like this to this. Like I said before, no air to breathe, no life. The troposphere is the most dense or thickest part of our atmosphere because the air molecules are tightly packed together. This layer of the atmosphere is closest to the Earth's surface. Gravity pulls on the air molecules, and that gives the air weight. We feel the weight of the air as air pressure. Air pressure is affected by gravity and the temperature of the air. Yeah, so when people say, I feel light as air, they don't know what they're talking about, dudes, because air weighs a lot. At sea level, there is 14.7 pounds of air pressure pressing against every square inch of your body. We don't feel the pressure, though. You know why? Well, the long and short of it is, our body pushes back. Yeah, take that, you heavy air molecules. You push on the body pushes back. Our bodies are constantly working to balance the pressure in our bodies with the pressure outside. Now, if I jam up to the top of a mountain, to a higher altitude, the air pressure gets lower. And it's harder to breathe, dudes. There are not as many air molecules up here because the gravity gets weaker as I go higher. So, I have to take more breaths. It also gets cooler as you go higher. The troposphere is between 5 to 9 miles high. The part closest to the Earth's surface has an average temperature of 62 degrees Fahrenheit, while way up towards the top of the troposphere, it's as cold as 61 degrees below zero. Brr, chilly. Right above the troposphere is the tropopause. Together, they make up the lower atmosphere. The tropopause is where birds pause during migrations. Just kidding. Actually, the tropopause separates the troposphere from the next layer, which is the stratosphere. Whoa, I suddenly feel this intense pressure, dudes, to ask you some quiz questions. Question 5. Where does most of Earth's weather take place? Is it A, the thermosphere, B, the stratosphere, C, the mesosphere, or D, the troposphere? Question 6. What form of recycling happens in the troposphere? A. The water cycle. B. The air pressure cycle. C. The carbon cycle. Or D. The sun cycle. Question 7. The steps in the water cycle are evaporation, condensation, precipitation, and is it A. Communication, B. Commendation, C. Collection, or D. Crystallization? Question 8. Air pressure, A, is greater at sea level than on a mountain. B, is less at sea level than on a mountain. C, doesn't change from one layer to the next. Or D, cannot be measured. Question 9. Why is it more difficult to breathe at higher altitudes? A, the air pressure gets stronger. B, water vapor gets in your lungs. C, there are fewer air molecules. Or D, there is more hydrogen. Dudes, let's check those answers. Question 5. Where does most of Earth's weather take place? You should have answered D, the troposphere. Question 6. What form of recycling happens in the troposphere? A, the water cycle. Question 7. The steps in the water cycle are evaporation, condensation, precipitation, and C, collection. Question 8. Air pressure is A, greater at sea level than on a mountain. And question 9. Why is it more difficult to breathe at higher altitudes? You should have said C, there are fewer air molecules. Alright, let's make like a tree and leave. Right on up to the next layer of the atmosphere, called the stratosphere. This layer of the atmosphere is about 31 miles high. Okay, there was something I was going to tell you about the stratosphere. Something to watch out for. What is it? Whoa! Oh yeah! Airplanes fly in the stratosphere. That's because pilots can avoid the weather that's in the troposphere by flying in the stratosphere. Dudes, I wish there was some place I could fly to avoid cleaning my room. But my mom can pretty much find me anywhere. Of course, when you get this high in the atmosphere, there are fewer air molecules. Gravity just doesn't have quite as strong a grip. Fewer number of molecules means less air pressure. Remember I told you that at sea level there is 14.7 pounds per square inch of air pressure? Okay, in the stratosphere, the air pressure is only 0.14 pounds per square inch. Not even a pound of pressure. Whoa. So instead of a bowling ball of pressure, it's probably more like a tennis ball. Now, without enough air pressure, those of you with lungs have a hard time breathing. You're probably thinking, hey Jet, then how come people can breathe on airplanes? Well, dudes, it's like this. Airplanes are pressurized. That means pressure is added to the inside of the airplane so those of you with lungs can breathe. From the inside of an airplane, you might not notice, but the air in the stratosphere is drier and even a little warmer than the troposphere. And that's because ultraviolet or UV rays from the sun get absorbed here. Too many UV rays can be dangerous. But lucky for us, there's a special layer of gases in the stratosphere that block a lot of the sun's harmful rays. It's called the ozone layer. Ozone comes from oxygen molecules in the atmosphere. The way the ozone layer works is really cool. It blocks out the sun's harmful rays, but at the same time, it lets in the energy and warmth we need. Some scientists are concerned about the ozone layer. The ozone layer is not indestructible, dudes. There are gases such as methane, nitrous oxide, and fluorocarbons that get into the atmosphere either through pollution or natural causes. Many experts believe that too much of these gases break up ozone molecules, which prevents them from blocking the sun's harmful rays. Alert! Alert! We got a big problem here! Scientists have found holes in the ozone layer. Well, not really holes, but places where the layer of ozone is much thinner than in other areas, so it's letting in more of the sun's harmful rays. Without enough ozone to protect us, those rays could damage our eyes, cause skin cancer, or even hurt plants and animals. The good news is that we seem to have caught on to what hurts the ozone layer. We've put a lot less of those ozone-destroying gases into the air. Yeah, scientists are hoping that in a few decades, the atmosphere will produce enough ozone to patch up those holes. So, if we don't pollute, that would help a lot. Phew, what a relief, dudes. So far, we've seen 2 layers of the atmosphere. All these layers are so important because they work to keep our planet just the right temperature. Not extremely hot, not extremely cold. Dudes, without all those gases, Earth's average temperature would be like 0 degrees Fahrenheit. Way too cold for life. But our atmosphere has what we call a greenhouse effect to keep just enough heat inside. Check it out on my Megadad Aristatron. Sunlight passes through the Earth's atmosphere. The gases trap the heat inside so plants can grow. The land and water absorb some of that energy. What's not absorbed goes back into the atmosphere, and some of that energy radiates or gets sent back into space. If all that energy stayed in the atmosphere, it would get too hot. Now, hold on to your hats, dudes, because people can hurt our natural greenhouse effect. When we pollute, we send heat-trapping gases high into the atmosphere. Then we get big problems. Those gases can cause too much of the sun's energy to be trapped in the atmosphere. That's what's called global warming. The result is higher temperatures for Earth. Now, don't get confused between the ozone hole and the greenhouse effect. See, the ozone hole allows too much of the sun's harmful rays through. The greenhouse effect traps the sun's energy, causing a hotter planet. Hey, you know what the Jet Space Jammer effect is? It's where I ask you quiz questions and you answer. Here we go. Question 10. The main reason airplanes fly in the stratosphere is A. The air pressure is lighter, B. For greater speed, C. To save fuel, or D. To avoid weather. Question 11. The ozone layer is made up of A. Oxygen molecules that filter out the sun's harmful rays, B. Clouds that provide global shade, C. Air currents that control the weather, or D. Moisture over the oceans. Question 12. What might happen if the ozone layer continues to get thinner? A. More meteoroids could fall to Earth. B. The sun's harmful rays could affect life on Earth. C. Temperatures could fall. Or D. Oxygen could escape into space. Question 13. The greenhouse effect keeps the Earth's temperatures blank for life. Is it A, too cold, B, too hot, C, just right, or D, none of the above? Let's see how you did, dudes. Question 10, the main reason airplanes fly in the stratosphere is D, to avoid weather. Question 11, the ozone layer is made up of A, oxygen molecules that filter out the sun's harmful rays. Question 12, what might happen if the ozone layer continues to get thinner? The answer is B, the sun's harmful rays could affect life on Earth. Question 13. The greenhouse effect keeps the Earth's temperatures C, just right for life. Okay, let's move on up to the next layer in the atmosphere. We're going through the stratopause, up to the mesosphere. This layer is like 25 miles high, dudes, and it does something very radically important. The mesosphere protects Earth from giant space monkeys. I'm just kidding, dudes, but it does protect us from stuff like meteors. Yeah, without the old mesosphere, debris in space would come crashing down, like, on us. Okay, ow! Like a meteor falling on your head is way uncool. Thanks to the mesosphere, most meteors break apart when they pass through here. So when they hit the Earth, they don't make as big of an impact. Whenever you see a shooting star, you're actually looking at a meteor that's burning up across the sky. Of course, if a really big meteor comes through the Earth's atmosphere, it could get past the mesosphere without breaking up. That's exactly what happened thousands of years ago. Check out this meteor crater in Arizona. It's a mile wide and almost 600 feet deep. Oh, and one more thing. This is where some of the satellites orbit. All those communication satellites and global positioning satellites float around here, in the mesosphere. The satellites have to be made of pretty tough material. It's extremely cold here, dudes. Check it out. It is minus 100 degrees Fahrenheit. If we go a little higher, we hit the mesopause, which is our signal to pause and ask a couple of quiz questions. Question 14. The mesosphere protects the Earth from A, magnetic storms, B, meteors, C, solar blast, or D, lunar radiation. Question 15. What are you likely to see in the mesosphere? A, stars, B, birds, C, airplanes, or D, satellites. Question 16. Temperatures in the mesosphere are A, extremely cold, B, mild, C, humid, or D, extremely hot. Let's check those answers. Question 14. What does the mesosphere protect the Earth from? B, meteors. Come on, admit it. Some of you are thinking giant space monkeys. Question 15. What are you likely to see in the mesosphere? You would likely see D, satellites. Question 16. Temperatures in the mesosphere are A, extremely cold. Alright, time to leave the lower atmosphere and enter the upper atmosphere. We are now officially in the thermosphere. This is the largest layer of the atmosphere. Dudes, it stretches higher than 300 miles. as you go higher and higher into the thermosphere, it just gets thinner and thinner until you're in space. The hair on my Uncle Harry's head is just like the thermosphere. It just gets thinner and thinner toward the top of his head, until there's no hair at all. When I pointed that out to him, he told me to go spaceboard on the dark side of the moon. Touchy, touchy. The thermosphere is divided into two parts, the ionosphere and the exosphere. Yeah, my Uncle Harry didn't even have enough hair for one part. But don't tell him that I said that. Anyway, some rad things go on in the ionosphere. Check this out. See those lights dancing all over the place? Is it a party? No, my friends, you're looking at the northern lights, or the aurora borealis. There are also southern lights too, called the aurora australis. Those lights are actually electrically charged particles, also called ions. Get it? Ionosphere? Ions? See, the lights come from the sun. When there is a solar storm, the sun sends a blast of solar wind toward the earth. After a few days, it reaches the Earth's magnetic field, which pulls it into the ionosphere. The particles in the solar wind mix with the oxygen in the ionosphere and light up. Cool, huh? If you go higher in the exosphere, you will likely see, whoa, the space shuttle. That's right, dudes. The exosphere is the playground of astronauts. It's where they work, live, and play. But don't try to take any deep breaths here. There is no air in the exosphere, just a tiny bit of hydrogen and helium. That's why astronauts have to wear spacesuits if they leave the shuttle. And with no air, dudes, that means, like no air pressure. So, spacesuits in the space shuttle are pressurized. Beyond the exosphere, dudes, is space, the final frontier, where I rule with my supersonic, intergalactic solar-powered spaceboard. This is also the place where I ask you some questions. Question 17. The ionosphere and exosphere make up the... Is it A, troposphere, B, stratosphere, C, mesosphere, or D, thermosphere? Question 18. Blank caused the northern and southern lights. Is it A, tropical storms, B, shooting stars, C, blast of solar winds, or D, lightning storms? Question 19. You can find the northern and southern lights in the A, ionosphere, B, exosphere, C, stratosphere, or D, troposphere. Question 20. What is the last layer of the atmosphere before it blends into space? A, ionosphere, B, exosphere, C, stratosphere, or D, troposphere? Dudes, let's check those answers. Question 17. The ionosphere and exosphere make up the D, thermosphere. Question 18. The best answer is C. Blasts of solar winds cause the northern and southern lights. Question 19. You can find the northern and southern lights in the A, the ionosphere. And question 20. What is the last layer of the atmosphere before it blends into space? It's B, the exosphere. So we're at the end of our tour of the atmosphere, dudes. Hope you enjoyed the ride. From now on, when somebody comes up to you and says, "Hey, what's up?" I fully expect you to say, "Huh, well, duh, just the troposphere, stratosphere, mesosphere, and thermosphere." Yeah, and next time it rains, I hope you'll announce that the water cycle is at work in the troposphere. Oh, and next time a friend of yours gets a gnarly sunburn, say, "Well, dude, the ozone layer can only do so much. At some point, you need to put on sunblock." Oh, and next time? Whoa, look at the time. I'd love to hang, but the universe awaits. Ha, later, dudes.